Good evening. Today we are going to discuss about the queue operations in data structure. So first one is what is meant by queue. So queue is like a stack. It is a linear data structure that is used to store the elements in just like other data structures, but in a particular manner. We have an elements. We can store the elements in which first in first out behavior. So the queue is a data structure. We have the store elements of same kind. The components queues are stored in a first in first out. There are two ends collections, queue collections. One is front and rear. The queue has two ends, that is front and rear. So basic operations on queue. So one is NQ, another one is DQ, another one is peak or front, another one is rear, another one is full, another one is empty and size. So these are the basic operations on queue. So first one is NQ. So we are going to inserting an elements to the queue. So DQ is nothing but we are going to remove the removal of elements from the queue. Next one is peak or front. So acquires the data elements available at the front node of the queue without deleting it. So rear is this operations returns the element at the rear end without removing it. So is full. So validates if the queue is full. So is empty. Check if the queue is empty. So size is size. This operations returns the size of the queue, the total number of elements it contains. So these are the basic operations on queue. So this is a NQ and DQ. What is the front and head, back, tail, or rear? So NQ is inserting and DQ is deleting. So whenever the inserting a new element, the opposite side will be the DQ. We are going to deleting the element. So the front is the whatever the front, it will be moved first. So the operations one. So NQ. So it insert an element at the end of the queue, that is at the rear end. The following steps should be taken to an NQ, the inserting data into queue. Check if the queue is full. If the queue is full, the return overflow error and exit. If the queue is not full, the increment the rear pointer to the point to the next empty space. Add the data elements to the queue locations. Whether the rear is pointing, return success. So this is a NQ. So this is a coding. We are going to NQ the 5. The inserting a element is 5 into the here. So this is a rear and this is on front. So we are going to already we having a 10, 15, 20 and 30 and 40 will be there. So we are going to NQ here. So it will be stored in the form of this one. So when the 40 will be there, this 40 will be moved to the next position. And then 30 will be moved to the next position. So like this, it will be stored. So likewise, we see this, if capacity equal to rear, the system that outdone this queue is full. So else the queue of rear equal to data rear plus plus. So this is the concept. The queue of rear equal to data. So the data will be stored in the queue of rear. So the rear will be plus plus. So additionally, it will be stored. So this is the queue NQ. Next one is DQ. This operations removes and returns an element that is in front of the front end of the queue. The following steps are to be taken to perform the DQ operations. Check if the queue is empty. The queue is empty, return the underflow errors and exit. If the queue is not empty, they access the data where the front is pointing. Increment the front pointers to the point to the next available data element, return success. So here the void print is front equal to rear, the system dot out dot println, the queue is empty. So here this see this. So rear is we are going to DQ. The 40 will be going to remove. So the 40 will be removing. So the position will be changing. So see this, for I equal to 0, I is less than or equal to rear minus 1, rear I plus plus, Q of I equal to Q of I plus 1. So the decrement rear minus will be storing. So return. So operation 3 is front. So otherwise called as peak. See, the operation returns the element at the front end without removing it. The steps are to taken to perform the front operations. If the queue is empty, they return the most minimum value. Otherwise, return the front value. So see this, if in front of Q is empty of Q, the integer is minimum value. It is a Q of front end. Next one is rear. So the rear function is the element of the rear end without removing it. The following steps are to taken to perform the rear operations. So if the queue of the queue is empty, then the most minimum value, otherwise they return the real value. So operation 5 is empty. It returns a Boolean value that indicates whether the queue is empty or not. The following steps are taken to perform the empty operations. If the front value is equal to 1 minus 1 or not. If yes, then return true means queue is empty. Otherwise, return false means queue is not empty. So Boolean is empty. The Boolean is empty if front equal to minus 1, return true. Else return false. Okay. So operation 6 is full. This operations returns a Boolean value that indicates whether the queue is full or not. The following steps are to perform this full operations. Check if front value is equal to 0 and rear is equal to capacity of the queue. If yes, then it return value, return true. Otherwise, return false. So that's all about the lead code. That is queue operations. So we already seen about the NQ and DQ, peak or front, rear is full and empty, and size. So now we can go for this one. What is this? Is size. See this size of this size one. Size. This operation returns the size of the queue, that is total number of element it contains. See this, no parameters are passed, returns number of container. So here the public int some queue of integer my queue, new integer linked list. My queue of add of 1, my queue of add of 8, add of 3, add of 6, add of 2. So queue becomes 1, 8, 3, 6, and 2. So in this size of my queue dot size. So here it will be stored as my queue of size. So this is the coding of this one. That's all about the